So, in the video where I talk about how you can split games or software into features and components, where you work on each individual component separately in its own sort of isolated scenario, and then once you've learned and figured it out, you then implement that into your project. Well, someone asked if I could go through and do the full system. Well, someone asked if I could go through and show how it's done. I have a project, in this case, a game, a component, and then work on a component and then implement that into the final product. So let's get into it. So the project that I'm working on is a top-down 2D zombie survival game, and the example I've actually got here in the image is SAS Zombie Assault, which was a game that launched back in 2009, and it was essentially a Call of Duty Zombies sort of clone, but was a flash game and it was top-down in 2D. It has spawned multiple sequels because it's very successful, especially for a flash game. And I'm just going to mainly focus on at least on the first one, which was a very basic world, a little room, and the player could just buy guns, and there was actually a wave limit of 20 waves, and that's what it was for now. So it's very simple, and I want to start simple. I don't want to go into the much further later ones until I'm confident of building this simple version. If you're still not too sure, then think of Call of Duty Zombies, but as a top-down 2D game. That's what it really is. So they just survive as long as you can. Think of it like that. So now I had to know what I kind of want to do. Let's split that into components. What do we need for a game like this? A top-down COD Zombies game or SAS Zombie clone. So we're obviously going to need the zombies, so the zombie class. But that's if we want different types of zombies. There's going to need to be some sort of structure with their health, the path that they take, which then correlates to the pathfinding over here. If they're alive or dead, as some sort of array, their speed. Perhaps their size of the level, if they're going to be, if zombies are going to be, some of them might be bigger, some of them might be smaller. The weapons, so sort of like zombies is going to be a struct. So if I want different weapons like an SMG, a rifle, even maybe a projectile based one like a grenade launcher or something like that, then I'm going to need a structure for that. So the speed of the bullets, perhaps the penetration. So if it hits one zombie, it might have penetration 2, so it can hit in a second one before the bullet appears. Others would also include like reload speed and even the sprite that's displayed. It could just be the same sprite but add a bit more depth. Obviously, if someone's going to hold a big machine gun, they're going to use two hands as compared to a pistol where it will be the player point up like that. The sprite, the top-down view. You're going to need some sort of collision detection. That with the zombies, so if the player hits it, but also between the walls. So we don't want to let the player walk out the map or out of the edge of the map. And alongside that, when the person fires, and the bullets are going to need to check if they're colliding and hitting an enemy and taking away their health points. And further along that, it's going to need a sweep and sort or some sort of optimized collision algorithm. It could be spatial partition, but I'm opting for sweep and sort for now to try, because it's a simpler algorithm. I think it'll be far more beneficial if the maps aren't huge. There's not going to be 1,000, hundreds of entities all at once. Only perhaps, I think, 100 zombies at max, and then it depends, obviously, the machine gun and the amount of bullets. In terms of pathfinding, obviously the zombie's going to need to be able to find a player, or at least find somewhere on the map to go to before then targeting the player. So some sort of algorithm needs to be done. The level generation itself. Now I've got two here, procedural and then handmade. So handmade would me handcrafting it, which would be the first choice, far simpler. But also, as I put like a sort of optional, not required, would be a procedural generation map. I think that'd be quite cool to make, and I think I could do that, but I feel like that's an additional requirement, not something that is required for the game. Make sure that all these other components are done first before really thinking about doing procedural generation, as it's very optional, and the desired outcomes could be the maps might be broken, glitchy, and all sorts. So it could be quite difficult. And lastly, the tile map. So the way it's going to render and look, and so I can just draw that it's going to be this texture, and it'll automatically choose the right corner, choose the end bit, choose the walls and such. So of these features that I've already implemented or already have code for, I already have a pathfinding script, jump point search, that's the one I'm going to use. I already have code for doing tile maps, so I can just reuse that. I already have at least the collision detection with steps, so that means if a bullet's too fast, it will still hit the wall. I actually did a whole video on that. For weapons and zombies, I'm pretty confident in. I haven't done that, so I will have to work on something like that in some way or another. And the one I am going to work on is sweep and sort for this video. I think that's, it's not too big, it's quite simple, and I think it'll make for a nice little component that I then can use in different areas as well that might need it, so different projects I may work on. So I'm just going to start with a nice blank template first. All it has is basically rendering a cube, and all I have is an enemy structure now, sort of like its dictionary, which then goes on to what language I'm using. In this case, it's in Odin, so that's the language I'll be working on. So what is sweep and sort? Well, it's actually called sweep and prune, or sometimes called sort, sweep, and prune. Is a collision detection optimized algorithm. And the way it does is that you check the lower or upper bounds of whatever bounding box you have, or bounding sphere, anything, in a sorted array, and you just check if they on an axis if they overlap. If they do overlap, then you check if the two objects have collided. If they don't overlap, you just ignore it. You don't do that calculation. And the way how it's beneficial is, one, obviously you don't actually have to calculate if the two cubes are intersecting, so that's, you've taken out some computation there. But also, let's say you have 100 entities that you need checked, 50 of them are on one side of the world and 50 on the other side of the world. You'll only have to check 50 because only 50 of them are going to be, let's say, on the axis overlap of your whatever you're checking. So if, or let's say the player is on the X side, 50 of the entities are on that X side as well, while the others on the other X side, that means they're going to be far away. They don't need to be checked. That's where the optimization comes in a perfect scenario. In a scenario where they're all clumped together or all on the same size, then all the checks will go through. So that is something that is worth noting for this game, because there is a good chance that zombies will all clump together in one screen, or just the fact that there's not going to be many enemies. So there's less than 10 or there's just one. There's no point having this sweep and sort, sweep and prune running in the background. And perhaps I'm also thinking of having a check. So if a certain entity threshold is met, then swap to the sweep and prune. That way we get, just a tad bit more optimization, and we're just not constantly ordering an array of like 10 entities when we could just, flip through and check through them all. Getting late, but I wanted to get this little part done, and that was just adding a nice little environment where a bunch of cubes are just spinning around. So if I run this, you can see we just have a bunch of squares or rectangles in this case, that are just bouncing across the walls, and we actually have up here the total checks. I've done it in the collisions that are occurring, and if we look at the code, we just have 10 enemies or 10 rectangles, and we just put them in a random position, give them a random velocity, give them the same height and width and height, and then add the append to the array. And all we're doing is looping through, updating the position, and if they hit the edge of the world or screen, then just deduct it, so they're now bounce the other direction. And we then loop through again, and we're just checking collision. So it's also, that's why it also had at least 10 collisions were occurring, was because it's also just checking itself. Because I'm not put a check in, say, if you're this one, then don't do the check. And I'm just drawing the total collisions and obviously rendering it. So it's really simple. That's my setup so far. And now we just need to add sweep and prune. So as you can imagine, we've got 10 things, but 100 checks going on. They're also checking on each other, so we need to do some sweep and pruning, and hopefully we can reduce this number, especially with 100, and we can find out how effective it is. It's been a few days, and I got the sweep and prune nicely implemented on my little component here. I just need to go through and double check, do some code cleanup as well, maybe add some comments to make it clear, and I'll put this up on GitHub as well, me to obviously use and learn, and for me to use. So let's give this a run, and I'll show you what we have. Here we go. So when they collide, they go red, and I think it's only showing just one cube is going red. Sometimes it's because of the way the sweep and prune actually works, but they are both colliding. And we see we've only got total checks of 40, and this is with 20 rectangles, because last time I showed you it was just 10 and we're getting 100 checks, and now we're only getting 40 despite having double. So this is like a huge performance game, and it's of a complexity of O(n) log n. And if you don't know what that is, it's called the big O notation, and it shows like how complex an algorithm is. So the more elements and the more operations, i.e. how long it takes to do. So when we're just looping through and checking every element, it's O(n) to the power of 2. So it goes up exponentially, meaning the more elements we have, it's going to take a lot longer. So when we have 10 cubes, we have to check the other 10 cubes. That's 100 elements, and so you can imagine that 20 is going to be like 200, and so on and so forth. So it gets very complex very quickly. And what we have is on, again, when we use sweep and prune. So this is pretty good, it's a decent amount, so it goes up almost linearly, which is really nice. So we can actually put in a lot of more elements before we get to the same operations count as just looping them through all. So I think will be perfect, and in fact good enough for our game or project. So I went back and double checked my code, and there was in fact a bug with my insertion sort. I was sorting by larger rather than less, so it was doing like maximum possible checks of 230 because I also added in the checks in here, so when it loops through active entities, and because it was all sorted by the largest to the smallest, it was never removing any, so it was doing like the maximum possible check, like a worst case scenario. But now when we do it, you see about 60, so it's number of elements plus possible collisions that can occur. So that's why we have a really good. So if I scale this up to, let's try like 50, we should have like 100 and a few left. There you go. So it's usually double, and then the possible collisions that can occur. This is a really good performance. I think this is what we need. So I'll just go over the code quickly. It's actually really simple. We have our structure called the edge, which is the value. That's our x value. Is it a start? So is it on the left? Perhaps the left is a better name for it. So it's either the left side of the object or the right side of the object. And its index, it's what it's referring to in the original array, the enemies array. So we firstly just populate the array. So we just go through the enemies and we just append their x, their start position, their end position, and the end position is depending on where your origin is. So in this case, I've not set the origin to anything, so it's just going to be the x position and plus the width. But if, let's say, the origin would usually be the center of the object, so that would be actually half the width. But in this case, I've not done that, so I've left as it is. I have two sorts. One is using Odin's proprietary sorting one, which would be like a heap sort. I've also invented insertion sort, and insertion sort is actually probably far better in this case than heap sort or some other sort. That's because once the array is mostly going to be ordered, insertion sort is very fast when the array is almost ordered, and so this is that. It's also the improved version where it will add a break. So this is like, you can get about ON in the performance, which is really good. Like I said in the big O notation, that's like just a really low line and really quick. So it's just the number of elements, so that's why it's really fast. Then we get to the actual sweep and prune, which is we create an active entity, so the ones we go are an object that we check. I'm also, because it's Odin and I need to manage memory, I delete this array every time the function ends, which is what the defer does. Defer deletes it until end of scope. So we don't want any memory. And all we do is we loop through, we check if edges start. I also update the position x of the value. If it's a start, then we know it's the left x, so I need to put it like that. And then we loop through the active entities and we just check collision, and then we append that edge into the active entities. If it's not the start, then we go through and we remove that, and we also update the value. We do an ordered remove, check if it still exists in that array. And because the reason that we can just remove it is because obviously all the edges are sorted. So when we find the start, we know it's an object, and then we can check within the current active ones. And when we progress along like a sweeping, we already know we can just remove the previous ones, the ones that are in the range. Now, if all entities are clumped together, especially on the x-axis, then you will get no performance gain because it's possible that they can all be colliding with each other. That is in rare cases, and in my case, that's just not. It's going to be really rare for that to happen. There's just not really much you can actually really do about that, except mitigate how many checks actually occur. Because even if you did like a spatial grid and everyone was in the same grid, you're still going to have to do a check on everyone. So there's only so much you can do. Now, I've kept one which is a simple sweep, which is simply you order your enemies array by x position, and then you just simply check if the x position of the next one in order is greater than, and then you don't check. And that one itself is, while it's like it takes so little code to change, it's actually incredibly simple that you get a huge performance gain as well from this one, even if you're just checking. Yeah, obviously if all the x positions are on one side, then you get no benefit. but still you can save a lot of performance on this one as well if you don't want to put too much effort in. And maybe in something like a sweep prune, you would, it's like that's too much, and then but this one's like, oh, I can just do the exact same normal collision, but I can just reduce it by a bit. And I also have some just traditional overlap X, some collisions, but I don't need them because the Raylib's own collision Rex is just completely fine. I just like to use that one instead. So I think next is for me to actually put it into my game and just check if it all works to as intended. Have a few enemies, shoot at them and see if they die and disappear, which is actually another thing. I maybe actually first I should implement a way that elements are removed from the array when an object is destroyed, which I think is quite easy because when enemy is died, I can then just check in my sweep and prune here if I do a check here if the entity even exists. If not, just remove it and cut it out. And also adding a new element. I imagine some sort of binary insert might be good. A good idea, rather than repopulate it and then resort it, which would also work. That's nice and simple, but I think a binary search and insert would work. I think I need a new camera. Look, I'm like bright orange, it's getting like brighter. Anyway, let me turn this disgusting thing off. There we go. So I've made some other adjustments now. I figured out that I had issues trying to reference this pesky index, so I decided to use Odin's maps. And a map is like a Python dictionary in that you can assign it you can be a string, basically like a unique identification. The array is essentially an unordered array, but it has like a unique ID that you can give it. So in this case, I literally generate a random int31-bit number. So that's like billions of combinations. So I'm never going to reach that. And then I just check, hey, is an element already exist here? If it does, regenerate. Keep regenerating until one doesn't exist, and it's basically never gonna, the odds of it actually generating a existing element is obviously gonna be very slim. So that's how we do that. And I had to also, I put a memory allocator in, and this is just to check if there's any memory leaks, which is why I just then delete these. So there's been no memory leaks, which is good. And yeah, I just changed this. So back in the sweep and prune, it's basically the same code, but this time we'll put in that unique key that we can then reference. That does make editing values a little bit more difficult, I should say, and that's because with a map you cannot directly edit structure values individually. So you essentially have to grab the value, then change it, then reinsert it as like a whole new struct in order to update it. Another thing is I need to add test with adding enemy in, but that is when I press a key I can delete an enemy. So if I run it, in fact, you can see that we have the checks here. Nice. I press on, I can start removing enemies. And you see the checks are going down, and obviously the collision is going out until there's 0 left. Nice. I just need to add a key and essentially insert it back in. That is the next stage, and I think it should be pretty simple. In fact, this code here, I could, rather than just looping through, I can instead just directly add it in. So whenever it's made, where's it made? So when it's made here, I can instead just insert it at the same time as well. So that means that would actually be more optimized. But this is just for a specific component thing. I'm just getting all familiarized with it. So that didn't take long. I figured it out. So I just now have the populate edge array, and I just pass it in this key. So I remove that loop, pass in the key, get the value, add it in as normal. If you want to know how I'm removing it, actually, when I do remove one, I delete the key from that map, and when I do my loop through, I first check, hey, does this key exist in that map array? If it doesn't, then I just do an order remove and continue. So you move on to the next item in that array. This is good because it means I'm not like regenerating a loop. For example, I could go when I delete it. So I just delete the first entity when I loop through. That's just for randomness. I could then do another loop here, go through all the enemies, find the elements that match, and then delete them. But as you can see, that's a whole new loop. But I could just do it in the existing loops. That's nice. So let's give it a run. So I run. Here's my enemies. You see, I have like 40, I think, and I can remove them all. And you see, checks are 0, and then I can press E to add them, and you can see the checks go back up, and they should collide fine. Yes, they should. Nice. So I have now done the last part, which is to implement it into the actual project. Here is the function. Maybe that's a bit zoomed in too much. No, it's fine. So I just have the two things: a zombie and a bullet, and it's essentially the same, but I just checking, getting the values first, check if it's start, and then I do check if it's a bullet, because I only need to check if it's a bullet hitting a zombie, and it's essentially the same. And then we just check if that zombie actually exists in its array. If not, then we just don't do any checks. If it does, then we just delete them from the array, and anything else is just the same pretty much. If I run this now, we can see who starts. Here's the path the zombies take, and I can shoot them. And as you can see, they collide and die. Perfect. This is pretty good. It runs the same way as in the main leap and just keeps checking before their positions are updated. In fact, I check it then just in case. Another thing is that if the bullet is too fast, it will actually pass over the zombies, and so we'll have to update this to accommodate that. But for now, look, here's my component is now into the game with my other collision detection systems I also have with here, which is players can check, and I actually have one separate for when the bullet collision is just simply hitting a wall. And so just to end it all off, I do have it on the GitHub with the original code here available ready for my component with a nice little example demonstration, essentially what I programmed in for other people to take in, and or for me to use as well, because obviously I've just simply ported this into that main project I was talking about, made the adjustments I need, and I just have a nice lovely readable example that I can always just base it off of. So if I have this like foundation that I've laid, and if I want to make a modification, I can take it, change it, and I have another project that I want to use it but it needs a different modification, again take it, then just like change it. I don't have to like sort of reverse engineer my code if it changes too much. So I hope you enjoyed that process of me just simply going through on how I make these components and how I introduce them in my projects and how I plan them. Remember to just like and subscribe into my videos, and also comment what you thought about this, and if you like this idea as well and want to implement it in your sort of development life cycle, then do go ahead and comment down below. Anyway, I'll see you in the other videos.